Cool. Hi, everyone. My name is Cornelius. Let's just get started. So just a quick introduction to myself. I work for Google as a artificial intelligence and data analytics expert, customer engineer, and supporting the entire Canada region and some parts of the US. And my job is basically, in essence, to go into a variety of different enterprise companies, such as Shopify and a number of others here in Canada, and basically show them how to implement Google Cloud technologies and how those technologies can help their organizations accelerate innovation and so on and so forth within their organization. So today what we're going to be talking about is basically the idea would be to how can we leverage artificial intelligence in our structured and unstructured data inside of BigQuery in order to basically facilitate better insights and create basically a lot more rich content to enrich the data that we already have, as well as how can we leverage BigQuery in order to actually interface with that data, both in unstructured formats, things like videos, as well as audio recordings and those type of things. You use Gemini in order to understand those data sources as well as summarize them, as well as structured data such as demographic data and so on. So we can use that in order to do things like build out strategies for marketing or a number of other types of use cases. So before we get started, I'm going to just do a quick overview of what are the issues when it comes to what is BigQuery and what does it solve inside of the industry. So in our industry, inside of the industry where we are working with loads and loads of data, we are just having accelerated data growth inside of the world right now, where before we worked with very small data sets and in data warehouses such as SQL Server and so on and so forth. Now we no longer have only that type of data. We've got millions, if not billions, of rows of data and content that we have to analyze in order to create proper insights. Now, the previous world where we tried to analyze this data just wasn't scaling to where we needed it to be. And so BigQuery created internally inside of BigQuery a product in order to analyze the data. Obviously, this data, when we created BigQuery as a product, we have a lot of data trapped inside of our data warehouses, inside of a variety of different structured and unstructured data sources, things like images and text and recordings, as well as all of our structured data, which is really hard to get to. It's very hard for us to actually understand how to access that data and then actually do something useful with it, because just too much of it. Like if you have a petabyte worth of information with a billion rows of information, how do you find that one record or two records in this massive haystack in order to actually find something that's of use? So that's one of the issues, and one of the big issues that we see in the industry is the fact that we are having a lot of people struggling to leverage all of the power of all of the data that they have, both structured and unstructured. Also, we find that 89% of IT leaders find investment into data streaming important. Now, this is basically for real-time intelligence. So before we had in data warehousing, we were content to a certain extent with non-real-time insights, where data could be arriving to our data warehouses maybe once a day. We could update it, or twice a day or three times a day in batches. However, today, with the demands of consumers online, we need to be able to activate and react to streaming data almost immediately. So if you can imagine, the moment you jump onto a website for an e-commerce store, being able to analyze a user's behavior as they are navigating on that website and immediately start taking the information from what they are doing on the website in order to inform the behavior of the website, in order to point them to specific deals or point them to specific pathways to increase their likelihood of conversion. Those types of things are becoming more and more relevant, and we are starting to need that data to be streamed in real time into our data warehouses so that we can react in real time to our users' demands. Also, obviously, the time and complexity in order to analyze this data is becoming more and more complex. Like before, we had these massive data warehouses, and that was enough. You could just go and run a SQL query and maybe get some insight. But today, we have all of these advanced tools, and this is becoming a more complex area where we now need artificial intelligence and all of these pipelines and so on and so forth in order to actually analyze our data. So it's no longer just a data warehouse. Now we need machine learning pipelines. We need Vertex AI in order to understand the data and a number of other things. So we do need to find a different way of working with our data. And another thing that is becoming more and more prevalent is governance, security, and a lot of the things around how do we make sure that sensitive data of our users are protected? How do we ensure that we've got encrypted data when required? When do we have, how can we make sure that we know what is inside of the data? How do we catalog our data? And all of those types of things is becoming something that's really important, but is not integrated in most data warehouses. And you typically have to have an external tool in order to actually analyze this data. And even when you do have that external tool, it's actually quite cumbersome because now you have a separate process by which to actually go through and try and do this governance and do all of those things together. And then challenge number 5, and the last challenge that I'll be, or the second last challenge I'm talking about here, is that we also struggle with efficiencies with people, where in the past we had data scientists, and then we had people who work in data warehousing and people who work in basically data management, and all of these different people were working siloed. What we want to do is we want to bring those people together to give them a unified platform to work on and give them an experience by which they can interact with data in the way that they feel comfortable. Whereas if that is with SQL, then you can do that. Whether it's with Python inside of a notebook, we want to empower people to do that. Or whether it's within a completely third-party system or web-based interface or whatever the case may be, we want to give people the power in order to access the data in basically any way they need and in a way that's familiar for them. And that's kind of why we build our products out in the way that we want. So what is BigQuery then? So just to give us an idea of where BigQuery is in the industry, the Forrester Wave report basically showed us that we are leading in a number of different areas, not only in the Forrester Wave, but also Gartner and a number of other places where Google has been shown as being the leader in data warehousing. As well as Forrester reports and IDC reports inside of the industry. So we aren't a new player to this block. Our current infrastructure for BigQuery is at a scale that is beyond anything that any of our competitors has. Even though you don't hear of us that much, but we are supporting not only Google's infrastructure, which is the entire internet, essentially as when it comes to Google search, YouTube, and so forth, but also massive companies such as Shopify and Spotify and a number of others who are Google clients and who are leveraging our technologies in order to analyze and visualize their data. So what is BigQuery? Basically, BigQuery is now a unified data analytics platform, which is basically used in order to analyze data across multiple nodes, computers across a variety of different regions in the world. So, for example, it's no longer the concept of trying to run a query on a single machine. BigQuery utilizes thousands of computers in the background or containers in the background in order to analyze data. And basically, you run one query, but that gets distributed and then calculated in memory and then returned to you as fast as seconds. And this could be queries that is the size of petabyte size queries with billions and billions of rows of data. We also have support for multi-format data that could be for images, text, recordings, and so on and so forth, as well as the capability for AI and ML integration. So when I'm talking about AI and ML integration, BigQuery is the only data warehouse for large-scale analytics that incorporates ML natively into SQL, so that you can not only run a query, but you can run machine learning directly out of BigQuery and analyze that data directly inside of BigQuery. So I can create models such as propensity to convert models, or regression, classification, neural network and models, autoencoders, ARIMA Plus models. You can run any of those types of machine learning models inside of BigQuery directly, natively, using plain SQL language, and run that entire MLOps pipeline directly out of your data warehouse, which is something that no other tool allows. And this is one of the big reasons why BigQuery is so powerful, because whereas in a number of competitor products, you have to separate your machine learning processes from your data warehousing processes. In BigQuery, those are integrated. So in other processes, we clean our data in one place, and then we have to send that data to another platform in order to actually use machine learning algorithms and so on and so forth on it, and then execute it there. In BigQuery, it all happens in one place. And that means that we get time to value to insight really, really, really quickly, which is a really powerful thing. Now, leading to that, obviously in our new world of machine learning and generative AI, Google's platform for analyzing or for executing really advanced artificial intelligence platforms is called Vertex AI. And in Vertex AI, basically, we have integrations between BigQuery and Vertex AI, so that we can take models that are in Vertex AI and we can execute them directly in BigQuery, again, using basic SQL. And this includes things like generative models, LLMs like Gemini. So we can have our data warehouse, and that data warehouse basically can run over a number of different records and then invoke LLM models such as Gemini Pro, Gemini Pro Flash, or a number of other ML models from Vertex AI, and actually execute record by record over each one of the data sources that is returned to us. This could be used in order to do a number of use cases like cleaning or generating insights from that data and RAG and so forth. So that's a good introduction to what BigQuery is and why we are positioned in the industry the way that we are. I'm now going to switch over to basically an explanation of how we can use Vertex AI inside of BigQuery in order to do a large language modeling. So what are the things that we need to consider? And one of the things is going to be, we're going to be talking about embeddings. What are embeddings? How do we utilize embeddings inside of our data warehouse? And then how do we use vector search? And I'm going to explain all these terms soon. And how are we going to then use that Vertex search in order to create insights from our data with Gemini? Before I go there, is there any questions in the group before I start?
No questions, thank you. It's clear.
Perfect, thank you. Okay, so let's have a quick look into what is embeddings. Now, embeddings is one of the foundations around how we work with Google search, right? So one of the things is if you go onto the internet and we start searching for data, we need to be able to find whatever data you have and find all of the related data to your search query. We have to find that obviously very quickly on something like Google search. In order to do that, we do a process called embedding on that data before it is incorporated into Google search engine. So we can do the same on BigQuery, but let's just talk about what are embeddings. Basically, when we create an embedding for a specific thing, basically what we're doing is we're thinking about it as a map. We create a map of a specific, let's start with like a map of a word. The word plant might be close in meaning, and you could think about this in terms of close in meaning in a map. Like think about a normal geographical map. And if we put the word plant on that map, it might be close to the word animal, but a little bit farther also in relation to food, it might be in that area, right? Whereas the word sock will be further away. So that would be somewhere in Antarctica, where the plant is maybe somewhere in Africa or whatever the case may be. But if you think about it like that, an embedding is just literally a coordinate of a specific image or word inside of a multi-dimensional space of meaning. So that's literally what embedding is and how we create embedding. So if we take the word food, and we can see that we have this picture of something that is food. We can see it's some type of cake. We can allocate a location like the same way that you would do it in a map with longitude and latitude and so on and so forth, and say that specific meaning of that word is located here, whereas the word, the animal, the parrot, is located at a different coordinate, but they might be fairly close, especially now with multimodal data with the color scheme here. We can see that kind of these things look kind of similar. So when we do a search, these things might come up, depending on how much data we have, these things might come up closely together because they are situated close to each other in this map of meaning. So now with Google search, obviously this embeddings is much larger than this. It's not only these basic words, and also it's not a three-dimensional map like what we have with a normal geographic map. We have a multi-dimensional map of meaning that words, images, and audio is being located in. So the process of embedding is actually an artificial intelligence process by which Google has already trained in this specific scenario, which we will take any word or any image or anything that you have inside of your data warehouse, or inside of your anywhere that you have the data, and we will place the data inside of this map that we have created. So you give us the image, and we will put it into this map of meaning. And that is basically what embeddings are. So we're going to be looking at how to actually utilize BigQuery in order to create this meaning. Now, once we have this basic way of mapping this meaning, that means that now when we search for a term, if I search for a picture, I can find other pictures related to this picture because they are close together in the map of meaning. Not only can I search it close, but if I take this picture of the dog, this will be coming up in this map of meaning between not only other related pictures, but also words, also recordings about dogs and stuff. All of that will come together. And when I do a single search for the word dog, I will find things like images and audio recordings and so on and so forth that is related to that specific search. So that is what embeddings does. And that's how we do Google search. So then once we've created these basic embeddings over all of this data that we have to be able to obviously search through this data, and that is done via a process called vector search. Vector search is our capability in order to take all of this multi-dimensional map, and we then have capabilities in order to find relevant data that are close to words that mean the same thing. So if I look for words like Christmas, I might find a lot of images associated with Christmas. So there's basically an example here. I have a picture or some type of picture that I want to look at. This could be in like Google search. When we do image search, we take an image, we submit it to Google as a query. It sees where that image is located in that map of meaning and returns similar things or close things, as close to the image that you originally submitted as it can. And it will find maybe the 5 most relevant or the N most relevant pictures associated with that specific query. And that's basically what the vector search is. The cool thing about vector search, it does not matter whether or not the picture looks exactly the same like the other pictures because, again, it's in this map. But also, if you were making a spelling mistake, if I said, if I was looking for Christmas images, but I spelled the word Christmas wrong, it doesn't matter whether you spell that wrong, which is why this is so good for natural language searches. It doesn't matter if I spell it wrong because the misspelled word Christmas would be close to the real word Christmas inside of the map of meaning. So it doesn't actually matter whether or not we make spelling mistakes or not. It will still be close to that area. So it doesn't matter how a user searches for something, it will still come out with relevant results. Before I move on, is there any questions around vector search and embeddings?
Well, I have a question related to your data, how we say earlier. So, it's like I understand it's more close like the tables, but in the vectors. So you can search more data, but I don't really understand how you put so much like it's a lot of so many data together in one place. Is it difficult?
In order to get so this is actually the whole point of BigQuery, right? So BigQuery is, so a lot of the times our data is very desperate. It's and our data is in a variety of different places, right? It could be data from logging data, it could be data from images, it could be data from audio recordings, it could be data from our data warehouse, and so on and so forth. So BigQuery is basically intended to be that centralized source of truth for our data across the organization. So, and I'm going to show you examples of how we can use BigQuery in order to analyze data that is in like images data, as well as any type of unstructured data, as well as structured data. So what we would typically do is we would feed or create data pipelines that will feed data into our data warehouse. And that's why we're saying we have both batch methods for loading data into BigQuery or streaming methods. And there's a number of like tools and resources that you can use in order to stream that data into BigQuery. So that is step number one in your data analytics journey, is to consolidate all of your data into a centralized data warehouse. Does that make sense?
Well, actually, yes, but I found that one question is related to language. Which do you use, SQL or MongoDB, something like this?
So in BigQuery, the great thing is that you can use SQL to do machine learning pipelines and so forth. So BigQuery has BigQuery ML, and BigQuery ML is just a SQL-based language in order to do things like regression analysis, autoencoders, ARIMA Plus, or all of the basics. And so I'm going to be showing you an example of how we can generate, for example, large language models using BigQuery and basic just SQL. But you can also use BigQuery inside of your notebooks and just use it like a data frame. So you can pull the data into a notebook, use that data frame, and then use traditional machine learning languages like Spark or PySpark and all of those types of things, or PyTorch and TensorFlow or any of those things as well. But BigQuery is really integrated into the Google stack. So it means that it's always accessible via those other methods. So it's very easy to pull the data in. And the great thing about BigQuery as well is it has, as opposed to, we've got our own version of a pandas library, which actually is scaled to the size of BigQuery. We call it a big frame. So which basically is a big data frame that can have petabytes of data inside of it, as opposed to, obviously, if you've worked with Python pandas, it's actually, the size is limited. And BigQuery, that size is no longer limited, and you can do analysis over billions of rows of data if you wanted to. Does that answer your question?
Oh, yes. Thank you very much.
No problem. Okay, so now what we want to do, though, is if we do semantic search in BigQuery, basically what we want to do is first what we're going to do is we're going to create embeddings over our data. This will be embeddings over your text data or the data inside of structured formats or an unstructured format. Then we're going to index that data just in order to make it faster for us to find it. I'm going to take you guys through the steps in terms of how to do this in BigQuery. So step number 1 would be creating an embedding. Step number 2 would be indexing these embeddings inside of our data warehouse. And then step number 3 would be able to use vertex search over this in order to find images and text data and so on and so forth. And then after that, this is where we start coming in with, like I was saying, the point of this entire talk is to actually take that and then actually bring it to RAG, or Retrieval-Augmented Generation. So what is, just for, to assume that not everybody knows what RAG is, RAG is basically a process by which we use a large language model, and imagine something like Gemini, where we would be able to, typically Gemini, we would just ask a basic question of Gemini. So we would just, if you wanted to generate an email for me based on XYZ, right? And so you can type that type of prompt in. But for larger organizations, and or even for yourself, a lot of the times we don't want that to be based on just Gemini. So Gemini was obviously trained basically with the entire internet in its back pocket, right? So all of the data that's on the internet has been used in order to create Gemini. And so when we ask it a question, it can typically return a fairly general answer to the question that we're asking. But a lot of the times what we want is we want to provide a Gemini with context. So we want to say, well, I want you to answer this question, but I don't want you to answer this question directly. I want you to take the data that I have, and this might be the data inside of my data warehouse, data from my text files or my images or my whatever. I want you to take this data that is my data, and I want you to use that as context to answer the question. So that is what retrieval-augmented generation is. It's basically just a process of feeding your artificial intelligence model or your Gemini model, giving it context. Go like, I want you to base the answer that you're going to give me on this data, so that it has the ability to answer that question better towards what you're doing. And I'm going to be showing you guys how we can actually achieve this using BigQuery, and everything I'm going to do is just going to be in basic SQL. And so I will go through this in real time, so I'm not actually going to do this. So let's just talk about what would we be able to do with embedding use cases in BigQuery. Obviously, we can find new support cases based on previous support cases. If we have a data warehouse where we have all of our support cases, we would be able to find similar things with vector search. We can also find one log entry that matches other log entries. We can find things like one person that matches another person in terms of demographic, age group, et cetera, or find a picture that is similar to another picture. And so we're going to be looking at these type of things in our demos from here on. Okay, I'm going to actually just stop here, and I'm going to jump into demoing what I am talking about, so that you guys can see how this works in real time. Before I go there, is there any questions?
No question.
No question. Thank you. Okay, so let's start. Okay, okay, everybody see my screen, hopefully. So basically, let's have a look at data. So this is BigQuery, by the way. So BigQuery is basically, you'll see it has a very similar feel to a traditional data warehouse like SQL. We've got data sets, and then in the data sets, we obviously have a number of tables, and these tables obviously have data inside of them. So as an example, this is a data set, and if I preview this data, it's just simple data and this scenario, right? So in this scenario, basically I'm going to start, and I'm going to build up in terms of complexity what I'm trying to basically show. So the first thing I'm going to do is, how can we use Gemini or large language model like Gemini? And we've got a number of different models, so it's not only Gemini, but like in this scenario, we'll just be using Gemini in order to create a to do some information, or to do some cleaning to this as a starting place. So I've got this loyalty data set inside of my data warehouse, and if I preview this, you'll see that the data is not consistent. So it's really difficult to work with inconsistent data when we need to work to standardize things. So here we can see that I've got a few examples here where the area code is in front of the telephone number with like brackets and so on and so forth, but certain other ways where it's just directly in there without the area code, as well as the addresses. I've seen in certain places I've got like commas, whereas some places I've got semicolons, and there's a variety of different like ways that this data has been formatted. Sometimes there's just spaces between things, other times there's commas and spaces between things. And I want to actually take this data and actually clean it up in such a way that I want to take each one of these numbers and addresses and get it into a consistent format. So how can I do that using BigQuery? So because we have the ability to, and I just have the query saved already, so I'm just going to show you guys how that looks. So in here, I am actually invoking, BigQuery has a function called ML generate text, which is based on a Gemini model, right? And then the generate text functionality that we have here basically allows you to pass in a prompt and then returns the results. So what I'm doing here is I'm combining in this data set for loyalty that I have here, I'm giving Gemini a prompt, and I'm saying to it, and I'm giving it, obviously when we do prompt engineering inside of LLM models, we need to first start by giving our a persona to our Gemini model. So this is an important kind of step, is to say, what are you? If we talk to Gemini, we always want to give it a persona, so that's part of prompt engineering. So in this scenario, I'm saying, you are a data cleaner. So we're telling Gemini, it is a data cleaner. And what I want you to do is format all these addresses in a consistent format. So that's the first point of prompt engineering, giving kind of like a persona to our Gemini model. Second thing is, what is the task that we want Gemini to do? So we want you to format the addresses that I'm giving you, all of the addresses that I showed you before, in the following way. It has to be street, comma, city, comma, province, and then zip code, for example. And then that's the third thing of prompt engineering, giving a number of examples. And so I'm saying, for example, I want you to, if I get an input that looks like 123 Main Street, comma, Toronto, comma, Ontario, MSV, 2K8, or whatever the case may be, right? And then the last step here is I'm specifying that I want this to be a least shot prompt model. So least shot prompt model basically just means that when it returns the data to me, I don't want it to say a bunch of things, because a lot of the times with large language models, when I ask it to do something for me, it will return with a whole slew of data. If I ask it, is an apple a fruit? It's not going to just give me the answer yes. It's going to say to me, yes, X, Y, Z. This is why it's a fruit. This is how we interpret what a fruit is, etc., etc. So it's going to give me a lot of context. But if I don't want it to do that, I need to tell Gemini to not give me all of that data and tell it for me, I just want you to return the address. I don't want you to return anything more than just the address, no additional context and information. And so that's the last part of my prompt, is basically just to say, like, I just want you to return the address with no additional data. And I'm doing a separate one for exactly the same thing, but in terms of telephone numbers and cell phone numbers in this case. I want you to return it for me in a consistent way. It must be formatted in this way. This is an example of how I want it, etc., etc. So now when I execute this basic SQL statement here, it's going to run, and it's going to go take that loyalty data set that I showed just now, and it's going to return that, but it's going to run these prompts over each one of the records, and it's going to clean the data for me. So I'm just going to do that. I'm going to run this data, and as we can see, it submits this to BigQuery, and now we can see that we have the old number, which was 647444888, but now Gemini has actually gone and edited for us and made it into the correct format. So, and as we can see now, everything is consistent. And the same with the addresses. We have the old addresses where there were sometimes semicolons, but now it has been replaced by commas and spaces in the ways that I wanted to. So this is one method by which you can invoke Gemini over your data in order to do something like cleaning of the data. So it returns cleaned data to our users after it's been invoked. Before I move on, is there any questions about this process of using Gemini inside of our data warehouse to run it over individual records? Any questions?
No. So I have some question related to your code. Which language do you use?
Say again?
This is specific language for Gemini.
This is SQL. This is BigQuery SQL. So this is just a SQL statement, which is being run on BigQuery, but it's invoking the large language model in here. So I'm just using it's something that you will get used to once you work in BigQuery. That's basically BigQuery is just a massive NoSQL database, but it has SQL capabilities. So you can analyze data using basic SQL. So in the basic same way that you would use traditional SQL, select all from table or group by and all of the normal SQL stuff. But it also has machine learning capabilities built in. So you can execute in the same way that you would execute a function to concatenate two fields together. We can invoke a generative AI function in order to execute this type of cleaning facilities using Gemini. Does that make sense?
Oh, yes. Thank you.
Not a problem.
Is there any other functions like generate text?
There's loads of functions in BigQuery. It can do anything. BigQuery is an analytical data warehouse, so it was created for the purpose of analytics. So you can invoke not only ML generate text, but for example, there's a number of machine learning queries that you can run, anything from regression models that will run ARIMA plus models, classification models, logistic regression, linear regression. Any of those types of things would also be able to be executed in the same way using the functions that I'm showing you here, as well as traditional analytics, things like standard deviation and statistical functions and so on that you can also execute using BigQuery. So there's loads and loads and loads of functions available, and traditional like cleaning functions, concatenation, as well as left and right functions in order to extract text. Or basic sums and averages and all sorts of things like that. Does that make sense?
Yeah, thank you.
And it's over, like I said, it's over literally, you can run incredibly complex queries over billions of rows of data and it will return in seconds. This was one of the most amazing days of my life is when I first, because I come from a traditional data warehousing world where I ran SQL queries on Microsoft SQL Server. And some of them I would start running on a Friday and it would only complete running on the Monday morning if I was lucky. So it would run for an entire weekend in order to get the analysis done that I needed. And the first time I ran a query in BigQuery over like literally 1 billion rows of data and it answered the question for me in literal seconds. I literally felt like Archimedes. I wanted to go scream Eureka naked in the streets. That's basically how I felt about it. But like it was a massive thing for me when I started analyzing and working with data in BigQuery. It completely changes the way that you actually think about data because you couldn't do this in the past. And that's what big data is really about these days, is being able to analyze this data in a lot of detail. But we no longer have to do the traditional statistics where we basically had to analyze data based on, in traditional statistics, we sample data because we couldn't analyze all of the data. Now with BigQuery, because the data is it's so fast, we can actually analyze all of our data at the same time, which is pretty cool. Okay, so now that you guys have an idea of how we could theoretically invoke a large language model inside of BigQuery like Gemini, let's look at how we can do vector search and embeddings and so forth inside of BigQuery. So,
excuse me?
Yes.
Please, can we use another model?
There's loads of different models in BigQuery. Let me just so as you can see, so there's loads of different things, and I'm just opening a few of them. So here's a few internally trained models that you can use in BigQuery ML, contribution analysis, basically, as well as linear regression, logistic regression, clustering for unsupervised learning for k-means clustering. You can use that, matrix factorization, principal component analysis, as well as time series data, and then LLMs and so on. And you can also even train your own models inside of notebooks and then use those models and execute them inside of BigQuery as well.
Yeah, okay. Okay, thank you.
It's not only one, has many different use cases. In this course, I'm just focusing on Gemini because that's kind of where what the course was about. So we want to get to the point of creating a RAG application, or Retrieval-Augmented Generation application. So for that, I need to do things like vector search and embeddings and so forth in order to actually get there. So that's what I'm going to just explain now. So the first thing that I need to do is create embeddings. So this is another function in BigQuery called generate embeddings, which basically takes a data warehouse. Now, let me just explain what this is doing first. So I have in here, I want to create a DAM. So a DAM is a digital asset management system. It's a common way of taking all of the images and creative content inside of your organization and finding a way so that users can search over images in natural language. So I want to be able to say, give me all of the images associated with Halloween, and that's to bring out all my Halloween related content. But internally, I want to build this type of application. So the first thing that I did in order to make this work is I created what we call a big lake table. BigQuery has the capability to create tables over unstructured data. So I've got a bucket just to inside of BigQuery. Here, this is where the bucket is. Open this. So a bucket, obviously, in BigQuery is just basically a place where we can, and the Google Cloud ecosystem is just a place where we can store data. You can think about it like Google Drive, but just much bigger. And so I have about 4,000 images here that I generated actually using BigQuery, but anyway, it doesn't matter. So as you can see here, there's a number of images, and this is associated with my store, my fictional store, which is a coffee store. And if you click on one of these, you'll see that this is an example of an image that I have. There's a number of different images that have been generated and that I've theoretically used in the past in order to do advertising inside of my organization. So I've got loads of different images in here, right? So what I did with BigQuery is I actually created a data set over this data. So over this bucket of 4,000 images that I have, I created a table. And this table, if I query what this table looks like, I can say, query this. I just want to select all out of that table. And as you can see, I have all of the metadata. So it's a URL of this specific thing, as well as a number of things associated with it. If there was additional context and stuff like that, it would be here too. But at the moment, what I needed is just the URL location of this data. Now, what I did is, after now I created this, I wanted to take these images and I wanted to create a vector search over it so that I have the image and then I put it into that embedding that I explained, that map of meaning. And then after I created that map of meaning, I want to do search over that map of meaning. So that's what I'm doing in this example. I'm taking those images and I'm generating that embedding, which gives each one of those images a location inside of that multidimensional space, so that I can start searching over it inside of that multidimensional space. So that's where I'm doing the generate embeddings. After I've executed that takes a little bit of time to execute, but after you do that, I actually create this table where it's not only the images, but what you'll see is I then have the vector or the location of this image inside of the space. And this is the coordinates in that multidimensional space. You can see it's a lot more than a three-dimensional coordinate like a map. It's quite a big thing here, but it's like that is the location of this specific image inside of that multi-dimensional thing. So this was a machine learning process that I applied over the image in order to actually create that. So after I've created this embeddings over this data set, so I created that. Then I do, after I do that, I do indexing. So I take that same data warehouse and I'm going to use indexing in order to go and run it. So this is basically these steps here, is to create basically indexes from that data. So first step is create embeddings to put it into that map. Second step is just to create the index around it. And then I can start doing things like vector search, which is this part, where I can now, using any prompt, and this is what goes in. Obviously, there's loads of documentation on the internet on how to do this, but just to show you guys basically how we would be able to do it, I'm searching here for Christmas. So basically what this is executing is over that embedding that I've created, it's going to go find me all of the images associated with Christmas. And if I run this query, it's going to return those images so that I can see that this is a few things here. It's saying to me, now this is a little bit hard to visualize, so I'm just going to do a quick jump into Looker. So obviously this can be any front end. I'm using Looker so in this scenario, I'm asking the question, give me scary images. And this is literally based on the query that I have there in the back, and it's returning to me the images that are scary images. If I wanted to change this to say, give me Christmas images, and I execute this again, it's going to run that same vector search and return some Christmas related images. So I can see there's a few Christmas related images and stuff like that. So it is doing a vector search over all of those 4,000 images that I have in the background, and then returning images related to my search query. And that's exactly what's happening over here. It's just easier to visualize in like a UI tool like that one that I just showed. Any questions about this?
Oh no, everything clear.
Okay. So after we've now done the vector search, so we have now basically what we've done up until this point is we've basically recreated Google search, right? I can now go into Google and I can type a question, and then the return of the question, it will return to me the top most relevant results, right? In this case, I'm actually specifying that I just want the top 5 most relevant results, but you can 2, 10, or 20, or 30, or however you want, right? So I'm doing the vector search, it's returning the most relevant results. And now the last step is to convert this into a RAG model. So what I want to do now, and this is one application, but you can use this in multiple different ways, is I want to provide this information, these images, I want to give these images to Gemini, and then I want to give Gemini a task. I want to tell Gemini, listen, based on these images, do this, create this, or do this. In this scenario, what I'm creating is I'm saying, and this is exactly the same thing. You'll see the vector search component of what I'm doing. It's exactly the same as I did before. It's this vector search over here. And it's the same thing, but now I'm just using the generate text, which we saw in my first example for our addresses and cleaning the addresses. But I'm using inside of the generate text, I'm using those embeddings and getting the images, and then giving the generate text function, which is our Gemini model. I'm giving it context using both the prompt, and I'm giving it a prompt now to say, propose some project ideas for a marketing use case using the context below. And so then I am like combining this with the vector search to say, give me the 5 top results from my query, like Christmas, right? So it's going to go find top 5 Christmas images. And then it's going to give it this prompt to say, propose some project ideas for the marketing use case based on these images. So it's going to go, hopefully, if I'm looking for Christmas, it will go and create a Christmas campaign for me based on this, the images that have been created. So let's run this and see how that works. So this now goes and finds those images, gives them to the prompt in Gemini, and starts creating a marketing plan for me. And as you can see here, marketing project ideas based on the image. So in this case, it did a few things, and it gave you social media posts and a number of different things, joy coffee campaign, target people looking for special gifts, coffee lovers, celebrating ideas, a campaign idea. We do a gift set promotion, offer a special gift set featuring joy coffee cup and a selection of gourmet coffees, etc., etc. So it's actually taken images out of my data warehouse, submitted it as a prompt, as part of a prompt to my Gemini model, and actually returned a marketing campaign that uses this data in order to give me an idea of how can I do a marketing campaign with this data. And that is basically the essence of how we would be able to take a Gemini model. We use vector search and embeddings inside of BigQuery, and we can then return and create a RAG application using that. I'm going to basically stop here and ask if there's any questions, and basically take it from there. Is there any questions around anything that I did today, or anything further that I can help them explain?
Well, no question at all. It was clear. Yes. Thank you.
No problem. Thank you very much. And I think, sorry.
The same for me. All is clear.
Perfect. Okay, that's great.
Thank you.
No problem. I can pass it back to you, Amanta, to